Alright, so I wanted to help you solve some of these problems, right? And problem 1 and 2, okay? Start with a force diagram. I'll use some color. Okay. I choose my system, right? And then just have weight and tension. Okay. And I might as well calculate the weight of the object. The weight is going to be the mass times the gravity field strength, right? So the weight is going to be 5 kilograms, that's the mass, times, I'm going to round 9.8 to 10 newtons per kilogram, right? So that means the weight is 50 newtons. I'll just write capital N. So I know the weight of my object is 50 newtons, right? And the tension should also be 50 newtons. So why don't I write this a little differently? Tension up, well, my logic is since A is 0, since I have 0 acceleration, the forces need to add to 0 as vectors, not as numbers. So if I place my vectors head to tail and I actually add them, these are the two vectors head to tail, I'll see that weight going down, tension going up, these forces add to 0, right? So weight down, tension up, they have to be the same exact magnitude, right? So weight equals tension equals 50 newtons, okay? That would be problem 1, okay? Problem 2 works a little differently. Problem 2, I got 2 ropes straight up, right? Here's my object, my system. My system is still the 5 kilogram mass, right? But my weight should be both of those vectors combined. So my weight, it hasn't changed. My weight is still 50, but now I have 2 ropes, right? If I do my vector sum diagram, I'll find that these 2 ropes have to add head to tail along with my weight, since the forces have to add to 0. So this is one of the ropes, this is the other rope. And so what I'm trying to show here is that since the acceleration is 0, my forces have to add to 0 as vectors. And when I add vectors, I have to place the vectors head to tail. Well, in this case, if the weight hasn't changed, which it hasn't, it's still the mass is still 5 kilograms, so the weight is still 50 newtons. Therefore, each of these tensions has to be 25 newtons here, and this one has to be 25 newtons, such that the weight is still 50 newtons. Okay, you can see in the diagram that the 2 tensions have to added together, their magnitudes added together have to equal the weight in this case. So that's problems 1 and 2. The next screencast will be problem 3. Anyway, I hope that helps. Have a good day.